Alright, in this question, there's a girl being lifted up in this platform, 100 metres high, and then she's dropped and she falls down. So a person on this ride is carried from the platform to the top. At the top, the trapdoor opens, the person falls down, and then she's caught. The diagram is shown here. Her mass is 60 kgs. And the platform travels up at a constant speed, 5 metres a second, constant speed. Right. What's Helen's apparent weight as she travels up? So the way I see it is that the normal force on someone, and some teachers call it the reaction force, but the normal force is your apparent weight. So we've just got to work out what's Helen's normal force. In this case, as she travels up at a constant speed. What does this mean? It means if there's a constant speed, is there any acceleration? No, acceleration equals 0. And because acceleration equals 0, the net force on her equals 0. So her forces are balanced. So the actual forces on her, as she's going up, are balanced. We know there's the downwards force of gravity, 60 kg, so it must be 600 newtons. It must be equal and opposite to the upwards force on her. Therefore, the normal, which is the upwards force, equals 600 newtons. Therefore, the normal force is the apparent weight, so her apparent weight is 600 newtons. Alright, carrying on. Here's the same diagram, but this one says as the platform approaches the top, it slows to a stop at a uniform rate of 2 meters per second squared. Now look at the unit for that. It's no longer velocity, it's slowing down at a rate of this. So this is an acceleration it's slowing down at. Okay, you've got to look at the units, ms negative 2. If it was velocity, the units would be ms negative 1. So what's her apparent weight now? Same as before, except we've got a new acceleration. So apparent weight equals normal force. Alright, let's work out the total force on her, because now there's an acceleration, there is a total force. The total force equals ma, she's 60 kgs, or 60, times 2 is 120 newtons. Now, if she's slowing down, she was in her lift, there she is in the lift, it's going up, but she's slowing down, therefore the acceleration must be going that way. So the total force in this case is a downwards force. That's her total force. 120 newtons downwards is a total force. What's the actual forces that make this up? Well, the obvious one is there's a gravity force on her. Same as before, that hasn't changed. Gravity hasn't turned itself off or something, of 600 newtons. That's gravity. What are the other forces that make up her total force? Well, there's an upwards force as well, a normal force. Now, for the total force to be downwards, this one has to be bigger than this one. What is the number here? That's 600 down, something up equals 120 down. The only number it has to be is 480 up. And that normal force is her apparent weight. Right, the last question in this set. I got the picture again, and now she falls down. So during her fall, Helen experiences apparent weightlessness. In the space below, explain what is meant by apparent weightlessness. You should make mention of gravitational weight force and normal or reaction force. Alright. Again, we're going to start off how we started everything else off. Apparent weight equals the normal force. That's the dot points. That's dot point 1. When she falls, she has only got gravity force acting on her. No normal force. So she appears weightless. And I'm just going to put another dot point in just to make sure I solidify my answer. She still has actual weight, due to gravity. Okay, so her apparent weight is equal to the normal force. When she falls, she's only got a gravity force acting on her. There's no normal force, so she appears weightless. But she still has her actual weight due to the gravity force.